think if you can hear me, I hope so. And I think we can start to be in time with the proposed agenda. So I would thank everybody to participate in this webinar and to present let's say the state of progress and the project Renew. It is an Horizon 2020 collaborative research project, and in particular, we would like to present the prefabricated solution we used and we developed and used for the deep renovation of the daisies in the project. There's this overview introduction by me as the coordinator of the project. Then the colleague Roberta Pernetti, again from Eurac. Eurac Research is an applied research center based in the north east part of Italy, in Bolzano. And then Roberta will present the packages and the way we use it for the performance assessment of the packages applied to archetypes. Then there will be a presentation more, let me say, technology that will be followed by Maximilian of the Gumpenmeyer company, German company, dealing with prefabricated wooden facade. A presentation of the demo case we already let's say finished in Oslo by the colleague Vera Luchina. At the moment, it seems she has some issues in connection. I hope she will be able to connect where, I mean, we can present together with Maximilian the implementation of the deep renovation in Oslo. And then there'll be also time for a short discussion at the end. For Renew, as I said, is a collaborative research project. There are different kinds of partners involved, and I'm presenting in the slide the project that are research and development partner, the owners of the building, partners providing technology or the knowledge of the technologies, and then consultancy companies that are more or less that follow the owner in the journey of the deep renovation. For Renew, it means there are 4 R's, so robust and reliable technology concepts and business model for triggering renovation of residential buildings. So robust and reliable are 2 main pillars of the project. And of course, we are talking about renovation and in particular of residential building. So the idea of the project is to develop technologies, usable methodologies to support the implementation of the technologies, and then the 2 parts feed into reliable business models, and also see the reference of the website. Yeah, we started from the fact that we are far from the target of 3% of renovation rate, even if it is in the European policy, and with some years, both from technical, financial, social point of view, and with the credibility of deep renovation approach. And so this is what we would like to developing technologies, methodologies, and business modeling with the aim to increase efficiency of all deep renovation process and to increase the rate of renovation process. Some examples: the prefabricated multifunctional facade. Maximilian will present later on. Plug and play energy hub is an hydronic unit able to connect different kind of existing and new hydronic systems and to manage the energy fluxes in building. A way to present the data coming from the energy consumption and indoor environmental quality, and to the different players, tenants, owners, and so on and so forth. A way to reduce the cooling need through ceiling fan, and we are working mainly on the control strategies. In this case, we are developing a tool to optimize the use of renewable sources, in particular PV plus battery, but also solar collector, natural ventilation, and daylighting. So the tool to optimize the use of the envelope includes different kind of strategies and technologies to exploit the local renewable sources. And then a specific study on the end of the renovation cycle for the technologies in order to increase the reuse and the recycling of the materials we are using. And then about the methodologies, starting from audit at the beginning of the process, just to decide and to drive the design process. And here the idea is to try to optimize the investment in effort and cost and the information we can get from the audit. To make easier to facilitate the design process and to involve the different players in a participative design approach, and also the best managing of the construction site as third methodology. And as I said before, all these to feed into cost-effective rating system that is a way to manage all the information and to implement actually the deep renovation. So from concern the technology development, let's say the lesson learned from the first application is the need of close collaboration among players, so owners, advisors, contractors, researchers, to improve technology solution and have actually a systemic package of deep renovation. The participative approach is very, very important. That again is something we foreseen in the proposal, and I mean it was demonstrated that it is very important. Important to quantify the evaluation of the performances with a functional mock-up to be tested in the laboratory, as well as with a numerical model and parametric simulations. And then the improvement and implementation phase that is to be, let's say, driven in a way by performances. So it is important that the different players always look at the performances of the solution. So for the case we already implemented, there was an initial concept of the deep renovation, some, let's say, prototypical action just to perform a pre-analysis of the renovation packages and of specific renovation package of the specific building renovated, and then the detailed technical specification for starting the procurement procedure. So a very detailed bill of materials to be used in the tender procedure. Yeah, this is more as an overview of project. I would let the floor to Roberta just to go a bit more in detail with the preparation of the methodology to develop the deep renovation package. If you have any question, please keep this question for the end of the webinar, and I mean we can have a more hopefully full discussion. I take the control of the situation.
Okay. Good afternoon to everyone. I also give my welcome to this webinar. Within this presentation, I will be going to show you the methodology and approach that we are adopting for defining and evaluating the performances of 4 new renovation packages across Europe. So, this presentation deals with the evaluation of the technology performance of the 4 new renovation packages. We will assess the suitability of these renovation packages across Europe, and I will give you some insight to the preliminary results of the simulation that we are performing for evaluating the performances of the packaging across Europe, and the approach that Roberto mentioned in the previous presentation to define the cost-optimal renovation intervention according to the priority of the users. So the starting point for us for defining the deep renovation packages is the definition of homogeneous area within Europe. We know that there are also other research projects that dealt in the past with this topic, and they basically adopted the geocluster approach that we decided to adopt too. I can mention the project FP7 in Fire and the Horizon 2020 project More Connect. So we decided to change a little bit the approach in comparison to this project, since we'd like to keep the national boundaries in order to ensure that the applicability of the renovation package is full, considering the minimum requirements provided by the single national law. So the three criteria for defining the mentioned geoclusters are to keep the national boundaries, and so according to the minimum requirements provided by the law in several countries, we define a more or less homogeneous area. The features of the building stock, so each geocluster has a similar share of multifamily and single-family house. And climate conditions. So in a way, also, this is a very important point for the definition of the packages. So this is basically to define some homogeneous areas in which we define and evaluate the performances of the renovation packages. So we have these 6 geoclusters. Then we have 6 reference countries, that Norway, Spain, the Netherlands, Poland, Hungary, and UK. And for each of these 6 geoclusters, these reference countries, we can take profit of the advantage of having one demo case or one early adopter building that I will explain later on what does it mean. But this way we can have a real support from national and local experts, and so we can validate the renovation packages in order to provide reliable and effective solutions. In the project for Renew, we will have 3 levels of implementation. We have the demo cases, where a full implementation of the renovation packages is foreseen. We have one case in the Norway that will be presented later on by my colleague Vera Lucchina. Then we have one demo case in the Netherlands and one other in Spain. As I explained before, all the methodologies and renovation packages defined within the project will be implemented in these cases. So basically we start from the audit to the definition of the renovation concept. We will make a performance assessment to fine-tune and to define a detailed design. Then we will proceed with the installation of the package, and we will monitor the performance. So a full implementation of the for a new concept. Then we'll have these early adopter teams. The early teams will follow 3 feasibility studies in 3 different countries across Europe, in which we will try to implement theoretically the approach provided by the project for Renew. So we will start with an audit procedure. We will define the renovation concept. We will find the performances of the packages proposed, and then we will proceed with a detailed design. In this way, we can try if really the packages that we find could be also applied in different contexts. And so, with the 3 more cases and with the 3 early adopters, we can cover with a reference country or geocluster in Europe. Then we have a third level of implementation that are the building archetypes, in which we will perform a real theoretical implementation of the packages by defining, according to the context and according to features of the selected archetypes, the best renovation package. It's important to point out that these packages come from the project, these archetypes come from the project Intelligent Energy Project Tabula, and so we selected from the Tabula database the best suitable buildings according to the building features and the possibility to apply the renovation packages as defined within ForRenew. So basically we will define the concept and we will make a performance assessment of a set of variants in order to understand which is the best configuration according to the criteria we'll explain soon for the geocluster that we are analyzing. Criteria of evaluation of the renovation packages, we defined a set of key performance indicators. These indicators deal with 5 thematic areas that are energy, environment, comfort and indoor air quality, economic issues, and building site management. Some thematic areas deal with the specific request of the European Commission within the work program. So we need to respect a target of energy saving, a target of cost reduction of the renovation, and a target of the reduction of the duration of the construction site. But also we decided to assess also other factors like the comfort, the production of renewable energies, the impact on the environment, and also the net present value of the renovation. That is also important to define the business model of the renovation packages. So, starting from all the issues that I just described, now I will be going to present the preliminary implementation that we are doing at the moment. No? So the first step is to translate the information included in Tabula that are effective but qualitative and general, and they are not really suitable for defining a detailed transient model, into quantitative and specific features. Therefore, we prepared detailed plans and we defined the materials and the thermal properties of each layer of the envelope. We defined more in detail all the features of the heating and HVAC systems. And we basically describe deeply all these buildings in order to be able to perform the simulation. So here we have 2 examples of a single family house and a multi-family house that we analyzed. We defined the baseline for each of the 24 building archetypes that we adopt for the simulation, for the analysis purpose. And so basically here I show you just the monthly energy balance, but you have to think that for each building archetype we evaluated all the key performance indicators in a way that we have a comprehensive overview of the current state of the buildings, and we can really evaluate the impact of the renovation packages on the building itself. Therefore, applying the renovation package is to define the renovation concept. So we have all the technologies defined within ForRenew, that are the prefabricated facade, the mechanical and natural ventilation integrated in the facade as well, the ceiling comfort operation, the plug-and-play energy hub, again the photovoltaic system and solar thermal system as optimized by Early Reno. So we have all these ingredients, and so we have to combine these ingredients to define a couple of renovation concepts. Here just an example to to explain to you that in some cases we have a simple insulation of the prefabricated facade, then we can integrate the ventilation with or without heat recovery to integrate the BIPV, and we can have an integrated solution with the BIPV and ventilation in the facade. This is just an example. For sure, the packages will include also other technologies defined within for Renew according to the need of the specific building and to the context. Just to make you aware of the work that we are doing, this is an example for the single family house in the Netherlands. Each package we define a set of possible variants, according to the different decisions that we can take. For example, the thickness of the properties of the insulation, or the ventilation rate, the efficiency of the heat recovery. So we create a large number of possible variants for each renovation package, and for each building we perform like 128 parametric simulation up to the several variants as defined. So these variants will allow to identify which could be the best solution for that specific context. So you have to think that for a geocluster we have some concepts that are in common, and then we evaluate these variants in order to define very in detail which could be the best renovation package according to the key performance indicator that I show you. And to do that, we set up a parametric simulation by using Transys and GE+, and we compare the results in terms of key performance indicators. This just to make you, to show you some very preliminary results on the energy balance of different renovation packages, so we can compare the performances in terms of energy, but also in terms of indoor comfort, in terms of economic issue, in terms of impact on the environment. For building archetypes, we will try also to create the performances in terms of building site management, so the duration of the construction site, but this is quite a theoretical analysis and maybe is not relevant as the other performances that we can really evaluate quite in detail with the performance simulation. To presentation, I would like to point out that all the results that we evaluated for the early adopters, for the demo cases, and for the building archetypes will be stored in the so-called repository of renovation package that is defined by the project for Renew. So, the repository will allow the user to have access to a very large number of simulation and performance evaluation of different technologies and different packages. And the repository will be also the background, so the basis with which we are going to develop the cost-effective rating tools, will be the core of the business model for defining the renovation package according to the priority defined by the user. So, for example, if a user would like to maximize the improvement of the comfort in indoor air quality in his building, we will be able to grab from the repository the solution that in his specific context and with that specific building much suit their needs. So, with this tool, it is possible to support the user in the decision-making process to start a new renovation process in his building. So I finished my presentation. I hope that it will be interesting and clear. And for any question, you can write them in the chat, and we can answer at the end of the other two presentations. Thank you for your kind attention.
Yeah, thank you very much, Roberta. It was very interesting presentation. You said 5 minutes. Maybe I can ask you to say a couple of words on, because in the process you followed, you performed some, let's say, calculating energy and comfort, but there are other areas presented related to cost, related to time, and all these will be part of the rating tool. So just to a couple on what in way the result of your simulation will be used in another tool.
Yeah, maybe I can show the key performance indicator once again, so maybe it is easier to understand. We have this table of key performance indicators, as you can see. And according to these 5 thematic areas, we'll have this repository of building archetypes that will include all the baselines and all the key performance indicators for each of these thematic areas. And then, basically, we don't say a priori which is the best renovation, because all the renovations are in compliance with the requirements provided by the European Commission. So we ensure that we will save at least 60% of primary energy in comparison to a renovation, and so we will reach some target in terms of cost and duration of the building site. Also, they can say, okay, starting from a very high level, good quality renovation package, which could be more suitable for my needs, and so you can say priority, and you can order the priority according to which is the driver for the renovation. So I would like to save as much energy as possible, or I would like to ensure that my the construction site would be the quicker as possible, or I would like to have the most cost-effective renovation, or the renovation with the lowest investment. So the priority of the user, and then accordingly, this cost-effective rating tool, we can evaluate for each specific building that you have. So according to your national context and according to the building, it is possible to refer to a specific building archetypes and then to classify the results of these building archetypes that can be adopted also for a preliminary evaluation of the building proposed by a single user. So this is the background to provide the decision-making process in order to give a preliminary insight of what will happen by applying a deep renovation package.
Thank you also for this, let's say, presentation of the use of the analysis of the archetype. Sorry, please.
To say, of course, the project is now in the halfway, so we need to further work on that. But we are approaching the second part that will be more operative, and in the next webinar we will present the results, the final results. So.
Right. Okay, thank you again. So now I will let the floor to Maximilian. To share screen. Yeah, Maximilian.
Okay, thank you for the introduction.
Thank you.
I'm trying to get rid of this. Okay, so to the part of the presentation where it's going to be more about the solution of the prefabricated facade frame elements, and those are multifunctional facade elements, which means that we integrate build services and other things belong to the renovation into the facade. So A short introduction. I come from the company called Gump & Meyer. We are a timber manufacturing company in Germany, in southern Germany. Around 90 people work in our workshop and offices. The company produces prefabricated timber with individually designed, so not really built houses, but all individually planned and produced in a workflow. Our field of action are small family houses to larger multi-family houses, office buildings, and industrial buildings as well. Maximilian Leland. I am a civil engineer. I work in the research and development and also in the project development and structural calculations. What I want to show you today is fabricated facade elements for renovation of buildings, renovation of residential buildings, as we learned already, because we are in the rounding of four new. And the new building skin which we build is more than a mere normal insulation, what I would like to show you today, and we are a digital workflow with a systematic approach for the renovation. The manual about the facades is the integration of the building services, and also to show you about solar energy generation integrated into the building skin. And then the last will be about the current developments which we are doing in Renew, the construction of new prototypes and the testing and simulation activities. The prefabricated facade elements, we claim that this is more than just a thermal insulation. We want to go further than only adding to the building, but we want to provide with addition more activity. Our elements are able to carry left in a way that we can add another story on top of the building, or we can also reinforce buildings which are subject to earthquakes, for example. And as you can see in the picture, the elements are prefabricated to a maximum level. That means that we have the windows and the cladding and the interior closing of the elements already prefabricated and transported to the site. So the question sometimes arises: should we renovate a building, or should we just demolish and build a new building? It's a very big decision in the beginning of a renovation project, and what I like to do that Demolition, for example, adds a lot of costs. It's time, effort that you need, and it's a lot of disturbance. You have to the tenants, and then you have disturbance of all people around the building. And would like to point out that it's an ecological point of view on this subject, that when destroying which is still able loads and to for the purpose it was built for, you will have to demolish and transport everything which produces for emissions, and then you will have to build a new building, which altogether in this very estimation would be 450 kilograms CO2 equivalent per square meter. The energy is preserved when you renovate the building by using the structure which you already have and do a renovation of this building. So once you made the decision for renovation, do you do a minimal renovation, or do you go for the minimal renovation? You will have investment costs in the beginning, and you will have a result of your action. When you did for example, the attics, the system will have a short lifetime and maintenance costs. So low in investment in the beginning will come back to you very quickly. It's only about the technical system. It's also poor in terms of aesthetics and the comfort conditions inside the building. Other aspects are always the building services. If you do a minimal renovation, you will keep the buildings as they are, and this will produce high lifetime costs, which are there already, and you don't change anything about it. Or there are high emissions from the running systems in the building, and if you want to change the building services and do this in a conventional way, you will have a lot of disturbance inside the building. And this means that you have to either move tenants or at least rental income. We provide a sustainable solution with the timber frame facade elements. We approach a deep renovation, which means that we apply robust and reliable solutions, as you heard already today, aim at low maintenance costs, solving the structural, architectural, and building physical issues of the building. So we change the services and we produce a very aesthetic new building, sometimes even with more space than you had before. We try to be on-site as possible, have a short and little disturbance of the tenant, and increase the comfort conditions inside the building. This due to the fact that we use natural material, timber elements filled with cellulose fiber. This is much more and provides a living quality than being bright materials outside of the building. To introduce you to the digital workflow and the systematic approach. Fluent thing about the workflow is that you have an individual building with individual openings and facade, and you will have to produce a new facade which really fits this build. So the beginning of everything is a digital measurement of the building, producing directly in a Fluent workflow a 3D model, which is adapted to the digital measurement. So there will be the production planning, and in the workshop, the prefabrication at a very high level, and afterwards the mounting at the building. And if I've done everything correct, the elements really fit to the building in a way that you can mount them very quickly at high effectivity. Prefabrication is solving the joints, which means it's designing and developing all details to the construction. So it's turning around the conventional construction process where you go to the construction site and start to have very small elements which you have to adjust to office of the building. It's really making thoughts prior before you go to the building site. So it's a bit of effort and time which you have to invest in the planning process, but it will pay when you go to construction and see that everything works very quickly and smoothly. Not show every joint to you and every detail. I just want to show you one example. This is the vertical section through the element where you can see how we can lower and the upper element in a way that we get an airtight connection. So in this kind of joint, which looks like a window frame, the air cannot move through the element joint, but it will tight connection. What you see in this detail is the connection of the element to the building. So vertical, the horizontal loads are taken at every floor by a fixation timber beam, and vertical loads are led to all those elements and at the basement. Of course, there are a lot of different solutions for this, and a lot of variants are up. But the thematic thing about it, this basic idea always applied, and then make only the changes which you need to do in order to fit to the building which you have. So to transport and mounting, you can see some pictures that typically is 1 story in height and up to 12 meters in length. And there are only rails. There are also other versions which are possible. The positive thing is that the timber is a very light element which you can easily shred and lift, and not lift but put to the place at the building. So the crane has to be able to carry the load at its very top. So about the mounting, that the scaffold always has to have some distance to the building, and you will be able to put inside the elements between the scaffold and the building. Here is approach to build multifunctional elements. So as I said already, it's possible to have additional stories, to have additional area, but the multifunctional thing also is that we're carrying element where you can integrate different functions of the building. So by making where you put it of insulation and airtight layers around your building, you would insulation for the one option is to just open the windows. Other options are to have decentralized ventilation devices, which will also do heat recovery, which is important if you want to passive house standard. As you can see in this prototype is that all the solar selector is created, and the ventilation openings can set the right side of the window. The sun shading is already included, the electrical connection for the sun shading, and also the window. Only about the technical integration, but it's also about having high aesthetic and trying to make very clean this with this thermal in this case. Here a more detailed through a multifunctional facade element. The idea is to reduce works inside the building. So what we can use is the space between the existing building and the new facade element, where we can change the part from the outside. So it's not necessary to go inside, rip everything out, and then change it again, which makes a lot of dust and noise. But it's possible to go outside of the building, to place pipes, and then the element is placed in before it. They cannot see it anymore, but it was very easy to touch the pipes. Also, section you can see ventilation ducts which have been placed above the window, and the electrical connection of the sun shading. And in the section you can also see it will be necessary to deal with the existing windows. So in facade elements we have new windows, and shortly before the new facade elements come, the window will be removed and a new window will be placed in front. You can think about option. You, for example, leave the existing window, put the new window and remove the window from the inside. So it's a very automatic thing where you can make changes, and all the steps will be this will already be made before the construction starts. Then, when you do the construction site, it will be a very quick thing, and making, for example, the new window sills from inside is a very short, which doesn't disturb very much the tenants. Here you see one example of an earlier research project where we integrated a larger amount of ventilation devices in that elements, and this will make a decentralized system for one story. So we distribute all ventilation ducts in the outside of the building, and also in the element there is a mechanical ventilation and heat recovery device. So centralized, this is for the whole building, but centralized for story, and can also see how it looks like in the workshop. So it's very easy to install all those ducts inside the workshop, and you have a very surrounding. It's not like standing on the ladder or the scaffold and having to do everything on site. Or even if you go inside the building, you will to disturb the tenants, and it's very difficult to work in this rich surrounding. So you can see the different parts of the ventilation system. This is also part of our developments. We can distribute the building services in a vertical shaft element, which is located in front of the building. In one step, you have this industrialized building component, which will very quickly to mount in front of the building and connect the cellar with each story. Here you can see in a more practical way what I explained to you before, how it's like on the construction site. So the integration of solar energy generation in the facade, I already showed you in the type of renew, and always about the aesthetics, combine different elements and the facade, but about the technical mission of diffusion of from the inside to the outside. This is part of the current activity going on, where we examine the conditions behind the solar thermal and try to make sure there is no condensation in this. To make the investigations, we have at work in Bolzano the possibility to simulate the indoor and the outdoor climate with the blue chips, which you can see there, which will be put in near to the prototype. This prototype, as you can see in the section, is put in front of a masonry wall, and the green part is the new prototype with the integrated heat recovery ventilation device. The first testing results arrived beginning of this week, and that dot marks the spot where we, for example, have the field that is very more complicated from a technical point of view. And as you can see in this graph, the results show that there is no sensation at the most critical point which we stay at a relative humidity around 40 to 50%, although the outdoor and indoor climate has been simulated in real conditions. Yeah, there are another tests coming to change those conditions and to get more results for different surrounding conditions. So this brings me to the conclusion of my presentation. The technique of renovating with the prefabricated timber facade elements is match and is already applied since years, and we have replicants and is a very well and sophisticated technology. For Renew, we have 3 projects, as you heard already, which will integrate the building services. So this is something which is innovative and still needs some more applications, but we are on the way to reach the possibility of reproducing it. But as you already see, a very complicated planning task, and the key to the success is that working in an integrative planning team where did not work on them, but together with the manufacturers and the planner for building services and all the types of this facade renovation, they cannot be separated, but in the plan already have be considered all together. And yeah, now to give word to Vera Lukina, who applied this technology in Norway, and we'll see more in detail how the application looks like.
Thank you very much, Maximilian, for the very interesting presentation. That's, let's say, practical, let's say, explanation of the we are trying to in for Renew. So Maximilian also supported the design team in Norway. Vera is going to present what happened there. Please, floor is yours.
Thank you very much.
Thank you.
Yes, I am. My name is Vera Lukina, and as Maximilian said, I was leading the demo project for RNU that was going on in municipality of Oslo in Norway. Just shortly about here. Big is a corporation in Oslo municipality. We and maintain all the social housing in Oslo, and it makes us the largest rental housing corporation in Norway. There are 25,000 people living in our houses, apartments, and we own about 11,000 of rental units. There are 330 to 50 whole buildings that we own, and they are the main focus of our building projects that are about 30 to 40 a year. Quite a lot. We also have a large rehabilitation backlog that we are working with. The age of the buildings are quite variable. So it is very interesting for us because we have many buildings and we really are looking for new solutions for them. So for RNU has been our first European project, and we have different kinds of motivations to participate in it. We have been very curious, very interested to support some innovation and some development. We wanted to try new experience and collaborate on an international level. And as I mentioned newly, we wanted to try new technologies that could help us renovate our buildings in a better way. With ambitious targets in Oslo municipality due to ecology and energy use, and at the same time, as I mentioned, we have a backlog that makes us carefully where we use our budget. yes, all the new technologies that can make rehabilitation more practical here and at the same time more ecological energy useful is really exciting. And at the same with so many tenants living in our apartments all the time, it's a really difficult task for us to be moving them and this all the time. So we are looking for the new solutions that won't make us do it in the same level. We're a building for participating in for RNU, and that happened in about 2015. It was time in this organization, but we tried to choose a building that will be suitable for this kind of a project. Not too large building, quite simple geometry. That's what the Haugere Center 17 to 19 at the end. It is a little building with 8 small dwellings. It's normally one person apartment with 1 bedroom, and as you see on the plan here, it's 1 living room with an open kitchen and 1 bedroom. So the apartment is small. It's only 2 windows in each apartment. Simple facade geometry made us hope that it will make the process simple. And one extra thing we considered is that it was enough space around to have a construction place. Things worked quite well. There were a few moments that we didn't discover before we begin designing the project. One was that we assumed a normal construction. It is normally in Norway timber frame facade all the way. But here we discovered that this porous concrete in the first floor. The thing that we discovered is that we actually didn't have so much of a foundation underneath the walls. So instead using the facade elements to mount on the existing walls, we had to build a new foundation around the building and put the elements on the new foundation. It became a little bit another type of the project than we were planning in the beginning, but it's well this way too. Yes. Of course, working inside the main for new targets, but we have our own goal. We're of course working with the use of prefabricated facade. It was one of the series. It is the first time in Norway we were using the prefabricated facade for renovation. We have really long tradition to build in prefabricated new buildings, but we have really new market for the prefabricated elements, both the facade and the roof. Another point was since we had to find our own provider, we really wanted to bring the technology to Norway so that our local manufacturer can take the market, at least in Norway. So Boligbygg and SINTEF's targets to do here. We were using the maximal energy saving. We didn't manage to come so high as the passive house that we've been to in the beginning. The reason is that we didn't have any space under the first floor, and really to achieve the passive house, you have to do something to the whole envelope. So really high on the walls and on the roof, and did some insulation around the building, but we didn't reach the first floor without removing the tenants. Put the tenant disturbance factor as the first priority, and then lose the passive house. We have quite exciting process of procurement of a manufacturer. We began just a little bit before we started the foreign use in autumn 2016, and we signed the contract just before the Christmas 17. We're really struggling and not almost giving up finding a local Norwegian producer. We almost signed a contract with one Danish, but it market, and we were looking for a manufacturer with a really strategical motivation, because this building is really not a project really very attractive. You won't earn that much of a profit on just building the new construction for this little building. So for some company, this motivation to come into this market like in 5 years or something. And at the same time, we as a municipality have some extra documentation needs and some extra requirements for our companions. So usually the first choice for the company. But we found, and I think the manufacturer that was chosen at last, Lindell Industry, that you see down on the picture. I think that they are lucky to be finding us too, because they are choosing further with this kind of construction now. Lindell is placed in the South Norway, so it's about 3-4 hours driving from Oslo and from the construction place. That is not so far and CO2 friendly, at least some level. The next step was picking the design team, and there we were doing a really careful job too. We began with a design group leader and chose one person, architect, a construction engineer, and energy designer. And we had our own timber element specialist. With a certain type of background and certain type of almost to be able to participate here. You really have to have a right motive to participate. So at the high point, we were probably like 15 specialists in the design team for the Lindell designers. At one point, we came to the hard design, and we really had to have the support from Eurac and Gumpenmeyer. With a lot of communication and job to coordinate for our targets and our local limitations and our local rules and norms. That I assume probably is normal in the international. But for us, it was new, and we really appreciate the support. Appreciate the early readiness tool to displacement and check the locations of the PVs. And Maximilian did really very much with the details on the and had the best questions and at the right time to avoid some problems afterwards. So personal experience helped us a lot in this process. And our little design partner, Sintef, was the one that supported us the most. They had some questions, some partners in the local market, That was very much to find the partners. They had their research support in the, for example, in physics. We had to take some crucial about if we will keep cladding or have to demolish the cladding. That would be probably more secure, but will make the building phase much longer. We had how we do the tight layer around the building, and choose about fire regulations that are quite strict in Norway. So research background of SINT helped us, and is still helping us when we are procuring the post-monitoring. The things I'm presenting now are really very material, because we really took over last week, and so it's very, very fresh. To do the correct choice of which renovation we will use in Norway. All of them were really simple to choose, like when you would use the prefabricated facade. In the beginning, that we didn't have enough height in the apartments to use the ceiling fan, and we have the need for it either. We used the early Reno tool later in the design phase, and that helped a lot. And the rest to do some renovation, because we didn't want to disturb the tenants, as I mentioned before, and that made us not change anything about the water consumption system. And we didn't really have any use for the plug-and-play energy hub. The strategies for components end of life, we required to consider this as in a Norwegian law. So we are yellow, so we do consider this idea, but for our new scope. There is also there are decisions to take about we are going to use the facade. Which kind of technology do we need to integrate? Really come to enough energy saving by only insulating, but we wanted to do a bit further, and then we integrated the PVs in the facade, because the most normal way to integrate the PV is to use the PV in the building is to put it on the roof, but then we integrated it and prefabricated. So we wanted to use the whole for our new idea. And we tried it. I'm sure it's also the first time in Norway we integrated the PVs in the facade. And apart solutions, and we're looking for the ways to integrate the ventilation ducts. And that the only reasonable thing is to probably integrate the fresh air ducts to the bedroom. We did it to try and to see how it works and to show that it's feasible and possible. A bit of building through the staircase. You see the old building wall and roof, and we build a technical room back side and the north side, where we put all the ventilation technologies, and you see that we isolated very much on the roof. We will describe now. We used beam from the with scanning of the building, whole design in the 3D in the building model, and then we sent this model and collaborated in this model with the production phase. They used this model to make the elements and to do the cutting. So the question was really crucial between the general construction design and the detailed element design. And very well, the guys were working together basically and together in the same model. And here is the production place. The cutting is automatically. I'm sorry. The production, the building of the elements is mostly by hand. So it helped a lot because we were doing some totally new things, like mounting of the PVs inside the elements was really new for us. So we had to think and build new solutions, technical solutions. It focus on the careful transportation to right on time because we didn't have place to the elements on the site. So we had to plan a correct order where what we should use in mounting, and then transport it to Oslo in this order by the right time. It is. The one of our proud moments. It's this summer, June, where we were mounting the elements, and just as Maximilian described, it went just perfect plan. Every suited on millimeter, and details were really thought through. Coordination on site was really good. We had to turn the elements around between the truck and the building facade, and we did it in air because we didn't have place to put the element and then take it out. But also this went very well. So everything around the elements mounting was really just perfect. I was enjoying watching it. You see, we chose to split the elements vertically. So we did the whole of the building. This was also to spare some difficult construction details, and due to not high building, it was really feasible. One of the main success factors was working with our that were living inside. I think this is one of the most important focus areas for all this, at least for social housing, because us are living inside the apartments, and many of them don't leave at the daytime either, so they are inside while we're working. There is some noise and there is some anyway, so they have to understand what we're doing and how it will affect, and how who we are doing and what's the plan and so on. So we had to do some special resource planning, use some specialists to communicate with tenants, and do some information work in advance, plan some communication in the process. Have a really high focus on safety in the process, because while mounting, we had to mount over the entrances that were in use. But this picture, the tenants were ready with the work. So from the neighbor buildings now are asking about when we'll come and do something like this. Overall results, I'm rounding up now. So I still don't have the final picture because it looks much better than here at the moment. But as I said, we really did just take over last week. So we sent a photographer there yesterday, I think. a few days you would be able to see a better picture. But it looks well. Very satisfied with the quality of the building, the solutions. We have much better installation. We're excited about how PV is gonna deliver the installation. Looks like working pretty well. We managed to do it in a relatively short building time, though it was some longer than planned due to some technical problems. And Lindell, our manufacturer, is working towards the certification of the system in Norway that is fine on the market. We are happy with this. It was just what we were hoping for and planning. I think I'm probably the last one, so if anybody has any questions to me or the previous presenters, now is the time.
Very much, Vera. I received a question on the, let's say, the chance to do the same without the research project. Let me say, because thanks to the research project, we cover the extra cost due to the fact that it's the first time that you do kind of say approach for renovation. Mm-hmm. So I mean, maybe your opinion on if this would have been possible without the resource project, and if you are going to say to redo the same, to replicate the same in other buildings. You said that you have 30-40 construction sites a year, so maybe you can have a chance to redo the same without the support of the research project. What do you think?
I think yes. I think it should be it should be working with this, and it looks really hopeful that the project is choosing to work further with this kind of solutions. Because as a building owner, usually do not describe which way to achieve our targets. We have the bid and we put some targets, and then we participate in the design process. But it's rarely that we would say that we do to use the prefabricated facade in this building. We would address it as we have to save 60% of energy. Then it's up to the design team and the producer and the subcontractor to which way they solve it. The normal way of doing the work. But I really hope that the market will be much better used for this kind of solutions further, and then we hit on our projects, because we're satisfied, and of course the budget is relatively high due to the first time approach. You know, it's always this way, that the first time you use much higher. But I really think that there is hope for it.
Yeah, and there's a question for Maxime. The ventilation unit that was integrated in the prefabricated prototype, and the question, I mean, you can read is about the reduced performance level because of the, let's say, the reduced section of the duct, because we have to hide the duct itself in the facade system, and maybe the performance not only in terms of air exchange but also noise, and in which way address the archetypes issue.
That's a very good question. It obviously the most difficult thing about integrating the ducts or the ventilation into the facade. In this where we where I showed you the picture from the building, there was demolition done before installing the so it was very detailed calculated how the ducts should be, how large the ducts should be. The ducts in the end turn out to be very high but thin, so this is not the most optimal for ventilation, but it still features good elements. But it's really it's the clue about the thing to have the ventilation device and the ducts outed in a way that it really works well. But it's possible, and I think it's possible because of those to have only one apartment and one story. If we would distribute it for a very large tenants and many tenants, then it would be more difficult. So the app is to have small devices and for parts of the building. And to the noise, yes, it is a problem, and also a research project, and it turned out that we didn't satisfy the level which we would have liked to reach, but it's quite limited. So always difficult tenants who didn't have such a system before to satisfy them afterwards, because they will always hear something which they didn't hear before. And we did meet the law requirements which we have, but for the tenants it still was too loud. So we succeeded in applying it and in reducing the noise by sound absorbers and by indicating the space between the and the ventilation ducts, but the tenants, it's still too loud. So next time we will have to improve the system.
Okay, and about the air tightness, I think.
Well, the air tightness has been solved, and it's basically about the connection or the path of the ventilation duct through the OSB boards, which is the layer of the elements and also of the building later on. This path through has to be carried, being with tape. It worked. Yes, we did a blower door test. So door test, only the ventilation device was closed, not the air ducts, the inlet and the outlets. So it was successful.
Thank you for the explanation. The question on, let me say, to replicate in other buildings around Europe. Let's say the objective of the overall project is to define a methodological approach. Okay, we are developing technologies, but we also are developing methodologies. So the aim is to give everybody all the, let's say, the box, let me say, to replicate the same in other parts of Europe. And this is the exercise we are going to do with what Roberta introduced as early adopters. The idea is to do them a short series of workshops in which they will present to us a specific case studies, and we will develop with them a feasibility study for a deep renovation using our technologies and methodologies. So in a way, at the end of the project, it should be possible to have a high replication of what we are doing in the three demos. I hope this answers the question. And then the end of life. Okay. as well. Yeah, end of life is related mainly to the technologies. So of course could be also replicated in other demo sites, because I mean, studying the end of life of the technology. So how to reduce the amount of waste at the end of the construction site, and yeah, how to reuse or recycle the materials we are using. And so we're mainly referring to the prefabricated facade, to hydronic components. That are the two main technologies we are developing. Yeah, Roberta said we would do another webinar at the end of the project, just to present the results, also of the 10 results foreseen within the forest project. Yeah. For Vera, question is if you can share the impact on the timeline. The time, I mean, you said that the most of the time was moved out of the construction site. As you are analyzing the data coming from the construction site, I don't know if you can say something about this specific indicator, the time.
As I mentioned shortly at the last part of my presentation, we did have to use a bit longer time on the construction phase than we were planning to. Do some technical questions, some delivery issues, and some other things. We had one leakage during the mounting process that made us postpone a bit, and then it was the summer vacation period. So there are these small details that were kind of unlucky for us, that made we mounting in 2 weeks just as planned.
Yeah.
All the rest small works that are invisible took much longer time and made us only take over last week. So this is the timing.
Yeah, thank you. And I know that you are stating what happened in the both in the drawing and in the, let's say, implementation phase, and I'm sure that you will let's say, achieve interesting results analyzing this kind of data. So we are at the end of this webinar. I hope the presentations were interesting for all. As coordinating the project, I would say to me are quite interesting results so far. As I said, we were going to do another webinar to present the final result of the project. So thank you very much to all. We will be happy to have you again in the next build-up webinar. Thank you very much. Bye-bye.